We are going to be starting our trigonometry section. So the first thing we want to do is to do a quick review on right triangle trigonometry. Right triangle trigonometry has to deal with right triangles only. We are going to learn later how to deal with triangles that are not right. But for now, we're just going to be dealing with our right triangles. So anytime that you're trying to define your trig functions, which our trig functions are sine, cosine, tangent. You're probably familiar with these three. These three, cosecant, secant, and cotangent, those ones are just the reciprocals of these first three. So sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals of each other. Tangent and cotangent. Okay, before you can define your trig functions, you have to know what angle you're talking about. That you're coming from. So where's theta? So for this one, I'm just going to go ahead and put our theta down here. Okay, so with respect to theta, this side over here, I have to travel across my triangle to get to it. This side is the opposite side. The one that's across from the right angle, this is my hypotenuse. And then this side will be my adjacent because it's right beside my theta. Okay, so now when I define sine, cosine, tangent, sine is just the ratio of the opposite side to the adjacent side. I apologize, it's the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. I'm not sure why this eraser is following me around. And then tangent is opposite over adjacent. And then these three are just the reciprocals. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is going to be adjacent over opposite. So if you know the first three, if you know these three here, then you'll be able to find these ones pretty easily. Here is an example. So anytime that you're asked to find all 6 of your trig functions, you definitely need to know all 3 of the measurements of the sides of your triangle. Well, this one, they only give us 2 measurements. So in order to find the third measurement, well, this is a right triangle, so I can just quickly do my Pythagorean theorem. A squared plus b squared equals c squared. And I can find that other side. So 5 squared plus b squared, and remember c is always your hypotenuse, so 13 squared. So this will give me 25 plus b squared equals 169. Subtract your 25 from both sides, and you'll get b squared equals 144. Take the square root of both sides. It's a triangle, so we're only going to need the positive value here. B is 12. And now you have everything you need. Sometimes it's helpful to go in and label the sides with opposite, adjacent, hypotenuse. So across from my right angle, hypotenuse. Looking at theta, go across your triangle. This is opposite. Looking at theta again, right beside it, this is my adjacent. So now I can go ahead and just fill in these ratios. Sine is opposite. So here's theta. Opposite, which is 12, over hypotenuse, which is 13. So 12 over 13. Cosine is adjacent over hypotenuse, 5 over 13. And tangent is opposite over adjacent, so 12 over 5. In order to find cosecant, secant, cotangent, all you're going to do is take these fractions, flip them over. 12 over, whoops, got to flip it. 13 over 12. 13 over 5, and 5 over 12. Okay, this example is pretty basic. Your answers all turn out pretty nice, but you do know that anytime you are using your Pythagorean theorem and you go down here and you go to take the square root, sometimes you end up with an irrational number. So maybe you would end up with like the square root of 5. You do not want to put that in your calculator and give the decimal value. You want exact answers, so we always keep our radicals in our answers. Well, if one of your legs is a radical, so if I have a triangle that's 1, 2, square root of 3, let me just start over there. And my theta was down here. And if I was asked to find the sine of theta, well, the sine of theta is going to be the opposite, which is 1, over the hypotenuse, which is the square root of 3. That's the answer, that's the ratio, but that's not in good form. So you always have to remember you want to rationalize your denominators. Multiply top and bottom by the square root of 3 for this one. So then you end up with 1 times the square root of 3, which is the square root of 3. And the square root of 3 times the square root of 3 is just 3, because it's the square root of 9. So that would be your final answer. Okay, so you're dealing with fractions as your answers. So you need to make sure that you're always reducing your fractions completely and rationalizing your denominators whenever necessary. All right, well, email me if you have any questions on this, and have a nice day.